This video shows a simple visual builder program that can be loaded into one of the Mintoris Basic program slots and run as an application. This application was written on a Samsung Galaxy Note 8 Android phone using a capacitive stylus and the Mintoris Basic built-in text editor. This program allows one to place graphic images, text labels and rectangular shapes on the display screen. The graphic images can be used as buttons. The text labels are used to display information and the rectangular shapes can be used to highlight text label backgrounds. This program is currently 1254 lines of Mintoris Basic program code. This program has 23 main functions that it can perform, which are the following: place graphic image, move graphic image, delete graphic image, view display screen, select grid options, select background color, clear entire display screen, clear only graphic images, clear only rectangular images, clear only text images, save screen image, build code template, select file directory, select file name, menu preferences, place text object, move text object, delete text object, select text options, draw rectangular object, move rectangular object, delete rectangular object, select rectangular shape options, exit program. The place image function allows you to place the currently selected graphic image on the display screen one or more times. The move image function allows you to grab an on-screen graphic image and drag it to a new location. The delete image function allows you to delete an on-screen image by simply touching it. The view display screen function will redraw all of the graphic images and text labels on the display screen. The set grid options function allows you to turn the snap to grid function on or off. You can also set the snap to grid resolution as small as 5 pixels up to a large size of 70 pixels. When the snap to grid function is turned on, the graphic images and text labels will snap to a grid point based on the current pixel grid setting when performing the move function. When the snap to grid function is turned off, the grid will be set to a resolution of 1 pixel and the graphic images and text labels will drag across the screen in a smooth motion when the move function is performed. The select background color function allows you to set the background to 8 different colors: black, white, red, green, blue, yellow, light blue, purple. The clear entire display screen function will remove all graphic images and text labels from the screen and the display will appear as a blank screen. The clear only graphic images function will remove all graphic images from the screen and leave the text labels and rectangular shapes alone. The clear only rectangular images function will remove all rectangular shapes from the screen and leave the graphic images and text labels alone. The clear only text objects function will remove all text labels from the screen and leave the graphic images and rectangular shapes alone. The save screen image function will save the current state of the display screen to a file called mipic.png, which will be stored in the graphics directory under the Mintoris data directory. The build code template function will generate the file myprog.base, which will be stored in the graphics directory under the Mintoris data directory. The select directory function allows you to select the directory where all of your graphic images are stored. For now, you should put all of your graphic images in the graphics directory, which is located under the Mintoris data directory. All of the files that the simple visual builder can generate will be saved in the graphics directory, which is located under the Mintoris data directory. This is a requirement of the simple visual builder program at this time until the file navigation section of the program can be improved. The select file name function allows you to select the file name of the graphic image that you want to place on the display screen. At this time, all of your graphic image files should be placed into the graphics directory under the Mintoris data directory before you begin to use the program. The menu preferences function allows you to set the list menu to 6 different colors: white, red, green, yellow, light blue, purple. The place text object function allows you to place the text label that you have defined onto the screen one or multiple times. The move text object function allows you to grab a text label and move it to a new screen location. The delete text object function allows you to delete a text label simply by touching it. The select text options function will launch another list menu that has the following 5 function selections on it: set text size, set text angle, set text fill, Set text color. Enter text label. The set text size function requires you to enter the text size as a decimal value and then press the OK button. This value is set to a decimal value of 150 during the program initialization sequence. The set text angle function requires you to enter the rotational angle for the text as a decimal value and then press the OK button. This value is set to a decimal value of 0 during the program initialization sequence. The set text fill function requires you to enter the fill value as a decimal value and then press the OK button. This value can only be set to a decimal 0 or 1. A fill value of 0 sets the text to be drawn on screen as an outline. A fill value of 1 sets the text to be drawn on screen as a solid color. The set text color function launches another list menu with 7 color selections to choose from. You can select from the following colors: white, red, green, blue, yellow, light blue, purple. The enter text label function requires you to enter the alphanumeric text string that you would like to place on screen and then press the OK button. The draw rectangular object function allows you to place rectangular shapes on the display screen. The move rectangular object function allows you to move the rectangular shapes to a new screen position. The delete rectangular object function allows you to delete a rectangular shape simply by touching it. The exit program function will exit you from the Simple Visual Builder application program. This program can generate a Mintoris Basic program code template called my.prog.base. The generated program code template application will treat the graphic images as on-screen buttons that can be pressed by the user. The programmer can then edit the program code template and finish writing the application code. When you first start the Simple Visual Builder program, the first thing that you must do is select a directory. This becomes the working directory for the program session, and at this point you are required to select the graphics directory, which is located under the Mintoris data directory. All of the graphic images that are to be used by the Simple Visual Builder program should be placed into their graphics directory that is located under the Mintoris data directory before you start to use the program. After you have performed the select directory function, the next step that is to be performed is to select the file name of the graphic image that you want to place on the display screen. After a file name has been selected, select the place graphic image function and wait for the pop-up message, place image, to go away. The pop-up messages tell you which main menu function you are performing when you are using the Simple Visual Builder program. When performing the place graphic image function, you can touch the screen where you want to place the graphic image, or touch the screen in multiple places, and the most recently selected graphic image will be placed multiple times. When you want to change to a different image, you must exit the place an image function by pressing the back button on the lower right corner of the bottom toolbar, and you will be taken back to the main menu. You can select a different graphic image file name by performing the select file name function and then go back into the place image function and place the newly selected graphic image on the display screen. When you want to move the images around on the screen, from the main menu select the move image function, and when the pop-up message goes away you can touch a graphic image and drag it to a new location on the display screen. You may drag a selected image across another image on screen, which will temporarily erase part of the image. When this happens, you can go back to the main menu and select the view screen function, and the entire screen will be redrawn. The information pertaining to each graphic image placed on the display screen is kept track of internally by a set of arrays, and when the screen is redrawn, the arrays are scanned to find out where each graphic image should be redrawn on the display screen. The Simple Visual Builder program uses 12 different arrays to keep track of the graphic images that are placed on the display screen. Using a capacitive stylus, you can place about 300 graphic images on a single display screen and still be able to activate the images as individual buttons. Each array is dimensioned to 1,500 elements. 1,500 divided by 300 equals 5 times the amount of array space as the number of graphic buttons that you can realistically place on a display screen. As graphic images are added to the display screen, the arrays are being incremented as each image is added. Each graphic image on screen is marked as being active. When a graphic image is deleted from the screen, it is then marked as being deactivated. When a graphic image has been marked as being deactivated, all of the information pertaining to it is still in the array structure. So you can add and delete images for a long time in a screen layout session before you reach the end of the array dimension of 1,500 elements. The modern-day Android devices have plenty of internal memory and external file storage memory. The array dimensions could always be set to a larger number of elements if there was a need to. Dimensioning the array elements to a large number like 1500 elements allows us to avoid having to write an array repacking algorithm which periodically scans the array structure and removes the deactivated graphic images and repacks the array structure with only the active graphic images. The 12 arrays are: bitmap upper left corner x coordinate, bitmap upper left corner y coordinate, bitmap lower right corner x coordinate, bitmap lower right corner y coordinate, bitmap width, bitmap height, bitmap file name, bitmap current on-screen center point x coordinate, bitmap current on-screen center point y coordinate, bitmap hold on-screen center point x coordinate, bitmap hold on-screen center point y coordinate, bitmap status active or deactivated. When you want to place a text label on the screen, you must go to the Select Text Options menu selection and set the 5 text properties first before you can place a text label onto the display screen. You must define their text size value, text angle value, text fill value, text color value, and then enter the actual text label that you want to place on the display screen. You can then place, move or delete text labels. There are 18 arrays that are used to keep track of the text labels that are placed onto the display screen. These 18 arrays are each dimensioned to 1500 elements. These 18 arrays keep track of the following information. The text string array keeps track of the actual text label characters. The text x coordinate array keeps track of the text labels on screen horizontal position. The text y coordinate array keeps track of the text labels on screen vertical position. The text angle array keeps track of the text labels on screen rotational orientation. The text fill array keeps track of how the text labels are to be drawn on the screen as either an outline or solid characters. The text size array keeps track of how large or how small the text labels are to be drawn on the display screen. The text red array keeps track of the text label's red color value component. The text green array keeps track of the text label's green color value component. The text blue array keeps track of the text label's blue color value component. The text status array keeps track of whether the text label is currently active or disabled. The text height array keeps track of the text label's height value. The text width array keeps track of the text label's width value. The text old x array keeps track of the text label's old on-screen x coordinate position. The text old y array keeps track of the text label's old on-screen y coordinate position. The text lower left corner x position array keeps track of the text label's lower left corner on-screen x coordinate position. The text lower left corner y position array keeps track of the text label's lower left corner on-screen y coordinate position. The text upper right corner x position array keeps track of the text label's upper right corner on-screen x coordinate position. The text upper right corner y position array keeps track of the text label's upper right corner on-screen y coordinate position. To keep track of the rectangular shapes on the display screen, 11 arrays are used, with each one being dimensioned to 1500 elements. The 12 arrays that are used to keep track of the rectangular shapes are as follows. The old x rectangle array is used to keep track of the old horizontal x position. The old y rectangle array is used to keep track of the old vertical y position. The current x rectangle array is used to keep track of the current horizontal x position. The current y rectangle array is used to keep track of the current vertical y position. The rectangle width array is used to keep track of the current width of the rectangular shape. The rectangle height array is used to keep track of the current height of the rectangular shape. The rectangle fill array is used to keep track of the rectangular shape fill value. A value of 0 means the rectangular shape will be drawn as an outline. A value of 1 means the rectangular shape will be drawn as a solid. The rectangle red array holds the value of the rectangle's red color component. The rectangle green array holds the value of the rectangle's green color component. The rectangle blue array holds the value of the rectangle's blue color component. The rectangle status array holds the active or disabled status of the on-screen rectangle. So in total 41 single-dimensioned arrays are used to keep track of both the graphic images, rectangular shapes and text labels that are placed on the display screen. When the program code template file myprog.base is generated, all of the arrays are scanned to generate the appropriate program code statements. Once you have laid out your graphics screen the way that you want from the main menu, you can select the build code template function to generate the program code template file called myprog.base file, which will be written to the graphics directory, which is located under the Mintoris data directory. To run the template file, you will need to exit from the Simple Visual Builder program by selecting the exit function from the main menu. Once you have exited the Simple Visual Builder program, you need to navigate to the graphics directory, which is located under the Mintoris data directory. Once you have arrived, you can select there myprog.base file, and Mintoris will run the program code template file that was most recently generated by the Simple Visual Builder program. You will see the graphic images appear on the display screen, and when you press them you will see a pop-up message appear that corresponds to the numerical position where they were placed inside the array structure in the Simple Visual Builder program. From there you can edit the program code template file and finish writing the program code for the application. Once you have finished writing your application and you are ready to create a file that you can distribute, you can select the Mintoris export function and it will create a file package that you can run through Android Studio on a laptop or desktop PC to create an installation file for your application that you can then distribute to other Android devices.